Joining me today is Dr. Richard Bormann. Thank you so much, Dr. Richard, for joining us and being part of RedSing Amplify. We're very privileged to have you. And Dr. Richard is the head of handling processes and dexterity research from Fraunhofer IPA, based in Stuttgart in Germany. And he has completed his doctorate, just waiting for the degree to come through, in engineering cybernetics from the University of Stuttgart, and he's also got an MSc in computer science from the Georgia Institute of Technology. His expertise is in computer vision, grasping, logistics, robotics, and he's done over 60 plus publications in this field. And his focus at Fraunhofer IPA is on robot assistance, intelligent robot learning, bin picking, which is what we're going to see today, order picking, palletizing, and service robotics. Thank you so much, Dr. Richard. Well, without further ado, I'm going to now invite Dr. Richard to take us through the overview of the AI bin picking solution. Over to you, Dr. Richard.
Thank you so much. And thanks also for having us here and for the kind introduction. We are happy to present our work on virtual feasibility assessment for bin picking today, which is a new paradigm in solving bin picking tasks. And before I really start with the topic, maybe let's say a few words so that you have an idea what Fraunhofer IPA is about and Fraunhofer Gesellschaft as a whole organization is about. So we are the biggest applied research organization in the world. And to give you a better understanding what this means, just think about we are the inventor of MP3. So this means we are taking new findings from science, from university, and transform this to new innovations that can go to market and help you to be better on the market, to have a better business, newer solutions, new innovations. And this is our mission. So we take new findings from science and make it available to real business. This is our mission here. And you see, there are about 32,000 employees in the world working for these goals in all aspects, not only robotics, that's what we do, but also in IoT, in life sciences, and every field of research and innovation you can think of. We have about 75 institutes in Germany and distributed all over the world as well. So like we have subsidiaries in India, in Japan, in the US, also in Europe, in Austria and in Italy, for example. So there are quite many places where you can get in contact with us. We are well known for having many patents, spin-offs as well, very successful spin-offs, and also a lot of revenues for each year, so 3.1 billion recently. Our institute, Fraunhofer IPA, is located in Stuttgart. We are, as said, multiple institutes, 75 institutes distributed all over the nation in Germany and all over the world. In Stuttgart, we have comprised 5 institutes, so IPA is one of them. We ourselves run about 1,000 projects each year with industrial customers and also research projects. We have 1,200 employees. And also a total budget of approximately 100 million euros per year. To give you some idea what we are working on, so like our robotics department is about 60 to 70 people working on different things. My team is working on handling operations with robotics, but we also are concerned with welding, with assembly, with safety for robots, robot systems integration, and all other topics that are relevant to real robotics operation in the real world for making business. But let's go to our team. We are 40 people working towards solutions with handling robotics. That means we have model-free and model-based picking, grasping operations with robotics. I will tell you a little bit more about the model-based approaches for bin picking in a few minutes. But we are also concerned with packing planning, to taking products in a nice arrangement into boxes, of palletizing and depalletizing, what you see in this video. I will skip the bin picking part because I will show you much more soon. But also we are concerned with empties handling, for example, which is quite interesting in at least the countries where you have to deal with empties. And furthermore, we are also concerned with digitalization of products, so we can make very nice visualizations and scans of products, which help to run and train AI algorithms on object detection and any kind of further complicated, complex solutions, which, for example, yields scalable object detection solutions, which are usable in order picking in warehouses and other things, solutions for mobile robotics, for example, that run in warehouses, as you see here, mobile robots that can pick up objects from shelves and store them in boxes for client orders, for example. We are also active in the field of laboratory robotics, as you can see on the bottom. So robots that retrieve chemicals from cupboards or that dose chemicals for their clients. And last but not least, all these intelligent behaviors only work really well for you if the robots can smartly set them themselves. So like you might only show them in a very intuitive way by teleoperation or by showing directly to the robot what to do, and the robot learns from your demonstration and does the real thing. So like we're also concerned with any kind of intelligent mobile manipulator like humanoids and other kinds of mobile robots that can do useful jobs in your business or in your production, for example. Even these robots can utilize buttons, for example, and press buttons, just as an example. All right, then let's get deep into the topic of today, which is bin picking. So bin picking itself is the process when you are served in your production, for example, with a box or a crate of parts that usually come in bulk, as you see in the videos on the right side, that come in bulk. You don't know exactly how they are located. They are chaotically served. You have the goal to take out one after the other out of these boxes and put them in an arranged manner into some machine, for example. So like machine tending is one of the premier application cases for bin picking. You take out single parts and put them in an ordered manner into the machine so that the machine can do some useful job with these parts. Yeah, and for doing this, we are working on this since 2003 approximately. So I was not starting this, I was just jumping into the team. And we have this in real operation in a real industry since many years. I think our first installations were about 2010, 2011. So we were among the first who really put real bin picking applications into real industrial operation in the world. And since then, we developed year by year many more nice functionalities, and I will show you a couple of them today. So most important to us is always to serve really the needs of the customer. So that means our solutions are always tuned for short cycle times. We are very fast in computation, and we also consider the whole process. So in the end, it's also very important when gripping that we have an intelligent gripping strategy that doesn't collide with parts and does not collide with all the rest of your environment in the end, as you can also see in the videos. In the lower video, by the way, you also see that the robot can unload machines, as you just saw the last seconds. So this robot in the lower part is a real industrial installation that is running on 2 stations, serving the machine and unloading the machine. I'm very unlucky that I cannot show more videos from real industry operation in automotive, etc. You know, they have NDAs and they don't really like others to see what's happening. But at least you get some idea, and the upper robot is a robot in our lab showing the recent technologies we do. So altogether, to give you some overview how bin picking works, you might have seen this in real world before. Bin picking can be divided into 2 major approaches, which is model-based bin picking. That means you have a cut model of your parts that you want to separate. And this is usually the case when you are in machine tending and you need a very precise placement of the parts into the machine. There we serve you with object detection in a robust way, with automatic grasp pose prediction, with automatic gripper selection, even if you have different grippers for taking your parts out of the boxes, and a full automatic self-configuration. I will show you a little bit more about this. So this is the machine tending part, where you usually have model knowledge. If you don't have model knowledge, so like in cases in warehouses, or when you do kitting, so like pre-order picking or assembly set kitting in a manufacturing environment, then of course you have thousands or 10,000s of parts, and you might not have models of all of them, or you might not want to set up a system for all of them. So in this case, you start working with model-free approaches that do not require any training and that can just work with any new part coming to you. This is what you see in the lower part of this slide, and also on the video on the right slide. There's a robot used for order picking, and by the way, it's very fast. This is live speed, so this is not accelerated. This is a robot which is supposed to pick out the right objects from a source toad into a client toad, where you really assemble some kind of order of a client. And the big idea here is that we not only in a model-free fashion take out the objects from the source box and drop them very randomly in the target box, but we are here concerned with a model-free placement algorithm that is also scanning these objects in the process, as you can see here with the camera in the middle, and also scanning the target box where is space for exactly this geometry of the object, so that we can end up with a very tightly packed target box that you can directly ship to the client because it's very densely packed. And all of this happens on the fly, ad hoc, within 50 milliseconds. So we don't know what comes to the system, but in 50 milliseconds, we decide where to put it in the target box, get a nice and dense arrangement of the parts. If we have some model knowledge in this process, because we have cameras in the process, we could scan the model from some sites, create a 3D model. We can even plan ahead. This is what you can see in the very small videos below. Planning ahead means we can already tell you in a few seconds how a total box looks like for you when you want to pack a certain set of objects in a very dense manner into a box. And as you can see, this is super fast, below 3 seconds cycle time with a gentle placement, and a lot of opportunities that you have own packing rules, for example. So this system is super versatile and already in successful operation with several clients in the market. The upper part just gives you another glimpse on new technologies available with our model-based bin picking solution, which is on the one hand handling entangled parts. So when you want to take out parts of a box, you might face the problem that these objects might entangle. So if you just lift up such parts, you might take out not only one but multiple parts, which is not what you really want to have in your machine. And so we have a detection algorithm that sees this part is prone to an entanglement, and the path planning algorithm that is really taking new path so that the part disentangles. And as another intuitive and innovative technology, we have this one, what you see here in this video, which means usually you often see parts shipped in boxes with some additional foil inside, and we can detect this foil, segment it out, and so that we only are remaining with the 3D data of our parts that we really want to retrieve from the box. So this is all technologies that help you to have a more robust bin picking solution in the end, and succeed in having a continuous operation with high performance in your applications. But nevertheless, before you really get there to have a bin picking application which is successful in your production, for example, you often face the problem that you have to invest in such a solution. And if you invest some money into it, you have to have confidence in investing this money in a solution that will really work for you in the way you want to have it. So the typical problem we see is many people are interested in running bin picking applications, but they have to be brave enough to invest their money. And in the beginning, you cannot do much more than taking the parts of a client to some suboptimal robot system in the lab, where you do some bin picking tests with it for some days. You get a feeling, it's working pretty well, but you can never fully guarantee how it's working because you're quite limited in the time you can invest in such a feasibility study with a real robot, which is, by the way, still not the optimal solution that will be served to you in the end. So you don't really know how the final system will perform when it's installed at your site. And to really break this problem, we have created a simulation, a physics-based simulation of the bin picking process that is really telling you the physics of the retrieval of parts from boxes. And this means you can use grippers, different grippers, as you can see in the lower video already. You can use, for example, 2-finger grippers, you can use vacuum grippers and others to simulate the process of retrieving parts. And by the way, usually you have, of course, homogeneous boxes with the same parts in the box, but our system is even capable of retrieving different kinds of parts from the same box with different grippers, and it can by itself decide which gripper to take, as you can see here in this video. Yeah, and by having this opportunity to really test the whole thing in simulation, we can give you some performance forecasts of the system to really understand how it will work later on in the real applications. And this is quite useful, and it also comes with a web service designed by Redsling, which helps a lot for setting this up in a very easy fashion. I will show you this in the next steps. So first of all, our system, our bin picking system, helps the customer a lot by having plenty opportunities of self-configuration. So in the best case, you only set up your environment as a digital twin, and the system totally sets up itself. So meaning it tunes the own parameters for the detection algorithms. It is automatically detecting grass poses on the object. So this is what you see here in the upper part, that you just upload a model of your object you want to pick up, but you don't tediously have to define, I can pick it up from here and from there with my gripper that I want to use. But the system is totally by itself analyzing how this works. That's what you can see in these videos, like for 2-finger gripper or for vacuum gripper. The system totally by itself defines where are good pickup points for these objects, which is very good, because in the end this means you are doing much simpler in setting up the system. So this means you don't need no expert knowledge, no real data for setting it up, and of course no tedious annotation of real data to get these systems trained for your application. This makes it very easy for you to set it up. And as a byproduct, but a very valuable byproduct, you can also conduct virtual feasibility studies with this physical simulation that is also used for setting up the system. So most importantly, it gives you the opportunity, without investing money into any hardware, to really test your solution you might run in your production by having plenty of simulations run and analyzing what comes out of it. For example, the KPI prediction of the cycle time, of the robustness of your grass, of the placement accuracy, where you put these objects in the end. Are you accurate enough for tending your machine accurately? Are you having a high box clearing rate? Do you take out the last parts of the box? This is a typical problem, that you might face problems in taking out the last parts of the box. And this requires a very sensitive gripper design, that it really works to get to every part in the box in the end. And this is either experience of your systems integrator. So if the system integrator has good experience, they design a very good gripper for you. But if they are not very well experienced, you get the first best solution, which is not the really helpful solution for your case. And then it's much better if you can use these simulation opportunities we show here, which gives you an optimization as well for the kind of gripper you use. So you can make simulations with different kinds of grippers until you have an optimized layout for really the best performance with your system. And the system also tells you if the whole cell arrangement, like the robots, the toads, whatever is like the sensor placement and so on, is really optimal for your application. So you can optimize your system to the max before you build up any piece of hardware, which is very, very useful, because I also saw in the past projects failing or taking much longer or costing more money because the first setup built up for the client was not working properly, and they had to adapt a lot, and in the end it worked well. But this pain can be avoided by just simulating beforehand and being safe with what you build up for your client in the end. And last but not least, our system, when it's once trained in this simulation, all AI's algorithms involved here are set up already in simulation, and you're ready to deploy it directly on the real machine, and you can run it directly. So you don't lose time, you don't have off time in your real machine in the end. You can just set up new parts totally in simulation, turn it over to the real machine, and the deployment really enables the machine to immediately start working with new parts. So no off time in your production when you want to change to new parts, which is very, very useful. So next one is just showing you how easy it is to set up. And Daniel will guide you through this process later on step by step. So on the left side, you see this is our web-based client. where you can set up the robot in your system, the gripper in your system, the sensor you use, which kind of bin you're taking into the system, which work pieces are there, and how your environment looks like. So you have a lot of customization of really building up a digital twin of what your system shall look like in the end and what your environment and boundary conditions are looking like. And once this is ready, then it will show you, you can just start setting up the system, doing a virtual feasibility analysis. And our backend is running these kinds of simulations with your parts then. And after a time of calculation and simulating and analysis, you will be faced with the KPIs predicted for this setup with your parts. And you can think about, is this technically feasible? Is this economically feasible with the performance I get out of this forecast? And of course, if you're not happy yet, go into the optimization loop, have the system, optimize your system for the robot cell and for the gripper layout, and in the end, be ready for deploy the thing on the real machine that you can build up with this competence and confidence. Okay, just quickly see this in real. This is our robot in the lab, retrieving parts from homogeneous and mixed boxes, as you can see here, with vacuum grippers or with 2-finger grippers. And this is how you use the system. So we have user management in our web-based client that we developed together with Redsling, where you can select, for example, the robot and so on. As I said, Daniel will show you more in a second. In the end, you can rearrange all the objects in a 3D viewer to put this together into the real setup that you want to run here in the simulation. So everything's super easy and intuitive. And this is fully connected to our software called BP3. This is our bin picking solution. Cloning the whole setup that you set up in the web client to a real simulation that you can see here. This is our simulation of the robot system, and conducting retrieval operations and analyzing how well it performs. And once it performs well, you can just put this on the real robot. As you can see here, this is the deployment on the real robot, and it directly conducts what you have trained to it in simulation. So here, for example, the robot is not only retrieving the parts, it's also taking the parts into some intermediate storage for quality inspection and then taking them to an Xbox or to a machine in the real operation. So just for you to understand, the whole thing is built up very modular. So this means we don't only have a very modular and nice to use web server for the user interface, where you can interact with the system in a very easy way. So without big training, even a standard user, a standard worker can use this. Everybody who can operate a tablet PC or a cell phone is capable of using the system. So you can set it up there, and it's connected to a high process controller or high-level process controller that is operating the whole procedure here for training and for operation. And we have separated the whole thing from the real robot skill controller. So that means the AI bin picking solution or other solutions from other vendors are totally out of the loop here as a single module with a standard API interface. So you can just put in not only our solution, you can also put in other solutions and compare different solutions with our virtual testing environment. Because of course, in the end, there are many bin picking solutions on the market, and one fits better for one problem, one is better suited for another challenge. So in the end, our simulation even enables you to compare different solutions here. And then we connect to our simulation server, which is running the physical process simulation on the one hand, and also keeping all the data, knowledge and models here. It's like the simulation data, configuration data, the KPIs you record during the tests, and the trained models in the end that you can finally deploy to the real robot system, so that directly runs there. So this is all modularized so that you can really work with this in a very flexible fashion. And as said, the whole thing can loop in different optimization cycles so that in the end you also optimize the design of your solution here. So last but not least, it also gives you a hands-on benefit if you go this way, because in classic bin picking systems, whatever advertising says, but in reality, you always need at least 1 hour of expert knowledge until you really feel safe in operating the system. Because at least if you just set up one grasping point, this might take you 1 minute. But if you have to set up 30 grasping points because you want to really take out every object out of your bins, then this already takes you 30 minutes, and so on and so on. So in the end, if you have this self-configuration system like we have here, you save a lot of time. It's like about 84%. And of course, it's not only time savings, most importantly, you save a lot of expert knowledge time. So you don't need an expert for setting up the system. The system itself is the expert. And this is your real benefit here, because the expert is super expensive, whereas time of just waiting a few minutes while the computer runs some computation and sets up your system is much more easy to tolerate and much better for your business as well. Coming to business, just as one of our very happy customers and collaborators, I would just tell that we are working together with Zahntechnik since 2010, 2011 in a very tight way. So they are one of our systems integrators that bought the software from us, that are working with us for a long time, have served many clients, and their clients are super happy with the solution. One of them even said this joint product of them and us is technology leading in the market. So just to give you some idea that we're working here really upfront of technology. And we also got some awards for this work together, which was really recognized well by industry. Okay, just to wrap it up, so we have many intuitive and innovative technologies in this system, and we are day by day working on more improvements and newer technologies. So be on tight what we have next for you in the next month. But just to wrap it up, so like we have simulation-based training, we have automatic grasp post definition, segmentation of any packaging materials or whatever might be in the box, so that you can just work with the real parts in your sensor data. We have AI-based, very fast detection of objects in the box. We have disentanglement functions. We can work with flat workpieces. So just to name a few things that we already can do with the system, and we will be capable of doing more every year. So this is a system really upfront at state of the art. So finally, because we are always asked, what is the USP of your solution? What is the advantage of using this? Our physical simulation, on the one hand, as shown, helps you to simulate all handling and grasping processes. And just to underline this is not a 3D visualization of the process, it's a real physical simulation of the grasping processes. Don't mix it up. Other vendors show you a 3D visualization. You can think about cycle times from this, but you don't know whether physically the grasping process will work or not, and whether your bins will be emptied in the end or not. This is only possible with real physical simulation that we do here. So this is giving you really meaningful forecast for your KPI before you really invest into such automation project. The automatic setup that we can give you really opens up new opportunities, because when it setups itself, you can easily put in 1,000 of parts, because now you can really scale up bin picking with many different parts, or you can change your parts on a daily basis, which is really a hard thing before. With current systems, you take maybe a half day of setting this up, and after a half day you don't care anymore because you have the next part already, the next half of the day. So with this system, you set it up quickly and you can really switch from part to part in a very fast fashion. The whole thing is super easy to use. Daniel will show you now at next. So even unskilled workers can set up new parts in your robot system. If you have to switch between parts very quickly, even your shop floor workers can set up a new part easily. We are, as Fraunhofer and also as our solutions, very agile and adaptive. So whatever you want to achieve, we are not the ones to sell you a system that is there as is, but you tell you our needs, your needs, and we will adapt our solution tailored to your order. This happened in the past frequently. This is why we are technology leading, because we already solved very many special things. And in the end, we are hardware agnostic. So it means you don't have a hardware vendor login. We can work with any robot arms dealer, with any make of robot gripper, with any make of sensor maker. We give you information what is suited for your parts, which is maybe not good enough, but in the end, you decide which hardware is your focus.